last chapter. Well, time value of money actually is part of it. It's not the whole thing, but that's what we're going to do today is the time value of money. You'll see when we get to it. It's not that rough. But anyway, so I'm going to check something really quickly. Nope, not that. This. Nope, not that. Let's see here. I'm just checking to make sure I got it all entered. I do. Okay. Well, let's go to the practice exam. And I'm just going to walk through this. If you have any questions, feel free to ask and stop me. But otherwise, we've been through this before, so yeah. Okay, one-time special order. And again, our regular production. Why it has productions? I guess we could have more than one, but the excess capacity. So we can do this without changing our regular production. So our alternatives are one-time special order and regular production, or just regular production. So we just look at the one-time special order. It's the only thing that's relevant. And we'll have additional sales. There's no variable costs. And the one you can leave out if you want, the additional fixed costs. Because they're not changing in this one, and because they're not changing, they're not relevant. Not saying they're not there, they are there. We still have to pay rent, but it's not going to change. Okay. So let's take this stuff first. One-time special order. So our sales are going to be for $7 each. Our additional units are seven times 5 is 35, so it'd be 35,000. So these be sales coming in. Our variable costs, so these are costs going out. Oh, that jerk didn't give them to you. Okay, here we go. So we have to get the variable cost per unit. I'm just going to do it here. Divided by 18,000. I think it's 5. It is. I should have trusted myself. Okay, so $5. This is variable cost. Okay, so that's $5. And additional fixed cost is 0. Doesn't matter if it's a plus or minus because it doesn't matter, it's 0. Our rent isn't gonna change or anything because of this. Okay, so our additional income will be 25,000 minus, no, 35,000 minus 25,000 is plus 10,000. Okay, should they accept the order? Yes. And I think I put Y on the test, so I'm gonna put that in there. Yes, they should accept it. Y, oops. Income will increase by $10,000. Okay. And again, this goes back to your econ classes in high school or in college, where they'll say that you'll produce as long as you cover your variable costs, you'll produce. So that's the idea: is that as long as you cover your variable costs, the marginal cost, maybe you might call it, but as long as you can cover those, you produce it, and the fixed costs are fixed. It's possible that they change in total, and if they do, then that's relevant. But if they don't change, they're not relevant. So generally speaking, fixed costs are not relevant if they don't change. Okay, make or buy. Question on that one? Okay, make or buy. And I have to go through and fix this too. Okay, so we're first going to do the cost to make them, and that's just adding all these up. Whatever that is, 5 plus 2, 14. 1,400,000. Better add these up. It is 14. Okay, so 1,400,000. And this method, we look at the costs only. We do not look at revenues. Revenues would be exactly the same. We're just seeing if somebody else should make them for us. So we're making them ourselves, and then someone comes by with an offer, Okay. Well, so we're buying from somebody else. We don't need to have the people show up to work. We don't need to have materials brought in, and variable overhead like the cost of running the machines. We don't need that. So that's going to be 0. Oops. Now they tell us next year's production 20,000 units for $60 each. Okay, they're going to make it for $60 each. Assume the plan will be either accepted. The factory overhead costs of 250,000 would be avoided if they were accepted. Okay, so our avoided fixed costs. By the way I'm showing you is the total cost method. There is a way to single out the what's only the relevant fixed cost, but we don't need to do it in this one. And usually it's easier to do it by totals anyways. Okay. Now we still need to buy them. So the buy offer is 20,000 units at $60 each. $1,200,000. So the buy offer would come out to a total of that. Okay, should the offer be accepted? Yes. Why? Company will save $50,000. The offer. Okay, this one's gonna be extra credit on the test. How much additional cost savings would need to be found for an overall savings of 120,000? So I'm going to say X equals the overall savings, or I should say additional savings. All right. So here's our equation. I'll put it down here. X. We're already $50,000 to the good, taking this offer. So we're going to add that. We're already $50,000 to the good. But the company says you know what, we're not going to do this unless we have an overall savings of 120,000. You know, we got to disrupt everything, lay off all these people, all this nasty stuff we got to do. So we're not going to do it unless we have save at least 120,000. So the question is, how much would it take? Well, we'll subtract 50,000 from each side. And so we'll end up with X equals 70,000. So that would be the additional savings. So we would tell them, look, you got to pull 70,000 out of your offer, or we're not going to do it. Okay. Looks funny. All right. Question on that one? Again, this is extra credit. If you don't, you know, this one is not, it's 5 points. It's not as important as the rest of it. But, you know, answer A is 25 points. This is 5. So if you don't turn that one in, that's, you still get an A in the class or an A on the exam. Okay. So cost the old scan. So here we have old scanner, new scanner. Hey, it didn't mess up my spacing. Who's a good document? Who's a good document? Okay, so our alternatives are that we don't do anything or we buy the new scanner. So we're just going to put in the buy the new scanner. That's the only different thing here. Okay. So things that are relevant to it. Cost of the new scanner is 40,000. We got to pay that out. Annual operating costs. Okay, so the operating costs are 25,000 for the old and 12,000 for the new. So the actual savings will be 25,000 minus 12,000 with 13,000. Yeah. I'll take the dollar sign out. There we go. Okay, so let's see. You're going to last for 4 years. Times 13,000. In the wrong spot. So $13,000 cost savings per year. Do it for 4 years. 13 is 52,000. By the way, the test you do not have to put in the pluses and well, you have to put in the pluses. If it's a minus, you should put it in. Pluses will be assumed if there's nothing in front of it. Okay, and if we buy the new machine, we can also sell the old one. And the current salvage value is 15,000. So we can sell this thing if we buy the new one. Okay, so additional income will be all those together. $27,000. And this additional income will basically be from cost savings. We're going to pay out 40,000 to have cost savings 52. We're also going to pick up the salvage value, but this will be the additional income. Okay. Should the new scanner be purchased? Yes. How much additional income will be realized? Okay. The consulting firm will realize 27,000 increase in income over the next 4 years. Yeah. Okay. Last one. So here's our company with the allocated costs. included. And it looks like the travel model looks like it's not profitable. And the question is, should we get rid of it or not? Now, actually, you could do this kind of simply. If the allocated costs are more than the loss, you should keep it. You know, it's not covering all 30,000, but it's covering some of it. And the difference between the, what, 19,000? So this is probably adding 19,000 to the income. But we come down here. So if the travel model is taken away, and these costs will have to be allocated to other parts of the business. Just for kicks, I'm going to put minus 15,000 on each of them. There's a bunch of ways you get allocated. Let's just say 15,000 for each. You pick up these extra costs that were being given to the travel model. So the travel model, we get rid of all these, but those allocated costs will still be around, so we have to add them to both these two. So this income will go down to 3,000. This one will go down to 7. And this will be at 10,000. $25 minus 22 is 47. The 45,000 will actually stay 45,000 because I have these two added to it. If you want, I can bring them out separately. Let me do something here. So they'll still have their old allocated costs, but they will also be allocated the 30,000 from the travel model. So these costs they're not changing, right? 30,000. So these are going to have to be allocated somewhere. There's a couple of ways you could do this one, by the way. One thing you could do is eliminate all of the allocated costs and run the equation again. This one kind of shows what actually happens to, what happens to this 30,000 of allocated costs to the travel model. Well, it has to go somewhere. Someone else has to pick it up. Should the wheelchairs be eliminated? No. How much additional income will be realized by eliminating it? None. Who's this? Mason. Mason Company will lose the difference between the 29,000 and 10,000, 19,000. first. Aha. So they're not going to have any additional cost savings. They'll lose 19,000 of income. Doesn't equal 0. Oopsie daisy. Okay. And that's it for the practice test. Oh, home model? Oh, yeah. Change that. This is wrong. This is actually a cut and paste error. So this should say travel model. Thank you. Good catch. Let me see here. So it changed that. Yeah. It's kind of funny. That's kind of the thing that they'd have on the CPA exam. I mean, I didn't do it on purpose. This was a mistake. I got two. I got my one twice. I still got a mistake here. Okay. The CPA exam, they'll give you something like this. They'll ask you about what would happen if the home model was deleted. You think it's the travel model they're talking about, but they're actually asking you something different. So you got to be careful on CPA exam to really read through and see what they're asking for. But this was an absolute mistake. So the travel model. Thank you, and change that on there, and I will make sure I change that on the exams. So change home model to travel model. Thank you. Before, make sure that I don't know if I have travel. I don't have travel model on that one either. But either way, I'll look at it and see. Okay. Any question on this thing? Okay, let's go to present value of money. Give me 1 second. I might have a better handout for this. Didn't I say that I taught it? I teach this in another class. This is the one I use for. Maybe we use this one. I guess. Let me check one more thing just to make sure I can. I don't like this one. I'm going to send you guys one more thing. Come on. I apologize. I tell you what, let's take a break. take a break. We'll come back, and by that time, I'll have there's a table that we're going to use to figure these out. So let's say be back at 237, 247. We'll still get done early today, I think. Okay. And let me share my screen. So I'll be back at 247. Okay. I was just talking to myself for about a minute there. So to chapter 21, we're going to do a few different types of decision making, but 21 is for long-term decisions. So it's sort of like this. If you were to split these two up, I think I talked about this last time. So chapter short-term decisions. Chapter 21 is long-term decisions. Okay, a few noted differences between these two. Short-term decisions generally only have variable costs only. Long-term decisions have both variable and fixed, although there's a kind of a note to this. So short-term divisions, only variable costs are what we're going to use. Generally, the fixed costs are not relevant for the most part unless they change. Long-term decision, we have variable and fixed costs, but the true part of this is that in long-term decisions, all costs are variable. Even the short-term ones that we call fixed would be variable. And I'll explain that a little bit. For instance, if we're making whatever we're making these things. We're making those in a factory, and maybe we have one factory. Well, in the future, we could have more factories, right? We could add more on. It'd be an additional. In other words, it'd be a variable cost to it. So in short term, we just look at the variable costs. What are the variable costs today? Long term says we'll look at variable costs and those things that are in the short term called fixed costs. But the truth of it is, all costs are variable in the long term. Maybe you have 5 manufacturing plants now. It's not going to change between today and tomorrow, but 5 years, 10 years into the future, it could change. Maybe you add 2 plants or you sell 3 plants, or all costs are variable in the long term. Okay, so yeah, so yeah, we'll leave it at that. Oh, there's actually one more thing here I do have to add. Actually, what we're talking about today. I should today's lesson is actually what I forgot. The time value of money. Time value of money becomes important for long-term decisions. Generally not speaking for short-term. If you're talking about taking a special order next week, the value of $1 between today and next week is probably nothing. I mean, even if you had higher inflation, it would be negligible. The amount between one day to, a 1 week decision is probably not relevant. However, if you take a long-term decisions, something that's going to happen over 10 years, say, now it does creep in, because of $1 10 years from now, because of inflation, it's not going to be the same as today. Right? You talk to your parents, they talk about going to the movies for $1 or something like that. Well, yeah, they're paying in dollars that were much more valuable than dollars today because of inflation. Those it's apples and oranges. A dollar 30 years ago is not worth the same as a dollar today. So we do have to take into account the time value of money. And that's what we're going to focus on today is learning about the time value of money. There's actually decision-making methods that we're going to do, but they're all based on the time value of money. So today, what we're going to go over is the time value of money. You guys have probably been over this in other classes. If you had finance classes, I'm 100% certain they had it, personal finance classes and all that. Now, the difference in today's that we're going to do is that for the decision making for long terms, we virtually always use the present value table. So we take dollars in the future and bring them back to today because we're making the decision today. So because the decision is being made today, we're using present value tables. We don't want to know how much we're going to have in the bank 8 years from now. It's okay, today we have this decision to make. Are we going to buy this equipment? Are we going to buy this building? Are we going to make an investment in this company or whatever it is? It's what we're making the decision today. So we're going to use present value tables. So today we're going to really beat up present value so that everybody knows that. And we're going to use the tables to do it. You're taking the CPA exam, they're going to give you the tables. They're not going to have it in a financial calculator. So we're going to use the tables and see how to use the tables to get these factors that we need to find the present value stuff. So today is just going to be on present value. We're focus on the present value. We're not going to get into the actual decision making today. All right. We don't need that. Okay. So I sent out the tables. They're also at the end of this handout. Now, they're at the end of this handout. They're not in a very usable form. There is actually a picture in here of the tables, whereas the Excel ones I sent out, we can actually go to the different ones. So I'm going to use this one. I think on the test I might include the tables right in with the problems. I usually do something like that. I'll figure it out. But anyway, so these tables are. This is one I just sent out, the present value table. And okay, let's go ahead and just do a problem. We'll see how this all works out. Okay, so grandma wants to pay her child $1,000 in 3 years. The discount rate, inflation is 6%. What is grandma's gift worth today? Okay, so today, this will be year 0. And say year 1. Okay, so this is kind of what grandma's going to send us, or send her grandchild. In 3 years, grandma's going to send out $1,000. And we want to know what that is going to be worth today. Okay, so what we're going to do is discount this back to today. Now they tell us that the rate is 6%. It's 3 years. And it's $1,000. We'll use that in a minute. Okay, so first thing I'm going to do is go to our table. So 6%, 3 years. The table we're going to use is a single payment table. This is a single payment. Okay, so coming over here. So we got a single payment table. Missing a line. Okay, here we go. It's for 3 periods. It's at 6%. And so this is going to be our present value in today's dollar. In today's dollars, what is going to the value of it. So in other words, $1 received 3 years from now will be worth about 84 cents today if the inflation rate is 6%. Okay. So let's go over here. So we got our present factor here. All right, so let's see here. Year 1. This is year 0. This is today. Now let's just say today. How about? Okay, we're gonna have Grandma's gonna give us $1,000, and each one of those dollars is worth 84 cents. So this is what Grandma's gift is worth today. Let's make it 80. So Grandma's gift is worth $840 today. Any question on that? All right, let's go to the next one. I figure out a better way to do the years. Yeah, I'll leave it. Okay, year. I did this wrong. Okay. So this one, Grandma's going to have us give us the same $1,000, but now she's going to give it in 5 years, and the rate is 10%. Okay. So coming over here, let me choose a different color. Yellow. So we'll go to 5 years. We'll go to 10%, and this is our factor here. Zoom in a little bit. I can't. Okay, so this is 10% for 5 years. So this is, I'm going to zoom in. This is 621. I'm in the wrong sheet. That's why I can't get out of the way. Okay, so everything else is going to be up here to be the same. So we're looking for the value today. Okay, so today, oh wait, I didn't put the money in. Okay, so today, $1,000, Grandma's going to give us. Each one of those dollars is worth a little bit more than 62 cents. So this is the present value of Grandma's gift today. Okay, so now you'll notice in both cases that Grandma gave us or gave a grandkid $1,000, but they're worth different amounts of money. And the question is why, and that brings us to the table. Okay, so I'm going to look at the table just in general first. You'll notice that as time goes on, money becomes worth less and less. If you go down here for the number of years, even at 1%, they become worth less and less and less. So as time goes on, the present value of that money is going to be worth less. Also, it depends on the interest rate. The higher the interest rate, and the thing about inflation, let's say inflation. The higher the inflation, as you go into the future, the less it's going to be worth today. So if you have higher inflation, if you have 20% inflation, that means $1 a year from now is going to be worth about 83 cents today. So if we have high inflation, the value of $1 going into the future is worth less. So as time goes on, it becomes worth less, and as the inflation rate goes up, it becomes worth less. Any question on that? Okay. Aunt Susie gives her niece a choice of $1,000 in 3 years or $1,200 in 5 years. The discount rate is 8%. Which gift should the niece choose? Okay. Well, I'm going to be lazy and copy this. Okay. So $1,000 in 3 years at 8%. This is not the right number. These are not the right ones. Or 1,200 in 5 years. Okay, so I'm going to do copying here. Right, and this is not right. This is 1,200. Okay, so this is our choices. Grandma says, let's see, the interest rate is 8% for both of these. This is for 5 periods. Oops. This is for 3 periods. And let's see which one we'd want to do. Oh, my spacing's all whacked out here. Ah, I know. It didn't help. Allow me to move these over now. You guys are having the same trouble I am. All right, let's see. Oh, okay. All right, well, I'm just gonna go through here, we'll see what happens. Okay, so I'm going to, okay, so 8% for 3 periods or 8% for 5 periods, and these are for 1,000 and 1,200. So Grandma says I'll give you 1,000 in 3 years or 1,200 in 5 years. Okay, let's look at the table for the so 3 years at 8%. Oops. 0.74. I think 0.74 just to. Okay, so this is what the 3 year at $1,000 would look like. And coming over to here to go to the 5 year, let's use a different color, blue or turquoise, I guess that is. I keep doing this. Okay, so 8%. So again, 5 years goes on a little longer in time. Each of these dollars are worth less, but we have more of them. So we'll have to see what this comes out to. Okay, so 1,200 times 6. $817.20. I'm gonna check my number on that one. So this is the amount for the $1,200. So which one would you rather have? Would you rather have the 1,000 in 3 years or the 1,200 in 5? 1,205, right? It's worth more. Okay, then he should take the $12,000 in 5 years. It is worth more than $1,000 in 3 years. So okay. So you'd rather have $817 than you would, excuse me, $817 is better than having 794. And again, these are in today's dollars. This is as of today. Right? So it's, while comparing these two are apples to oranges, the year 3 and the year 5 are two different things. The the actual value of them today, these are apples to apples. In today's dollars, we're comparing them. I don't know if I need to have these arrows in here or not. Okay. All right, now copying that down, I'm just gonna copy the whole thing, I think. Now everything else is the same here, except for the interest rate. Okay, now the interest rate is 12% instead of 8. So we're gonna go to 12% and 12%. Those will be different. Those will be different. All right, so let's go to %, 3 periods at 12%. So 3 years is 12, and at 5 years it is 5. Okay, so 3 years is 712, 5 years is 567. Okay, so let's plug those in. Okay, so we have 0.681. So $1,000 would be worth 681 today. The $1,200 would be worth a different number. It could be the same number. I doubt it though. What do I do here? This is wrong, wrong, wrong. You guys, why don't you say something? I do something stupid. I'm sorry. Let me try that again. 12% for 3 years. 712. 12% for 5 years. 5, 6, 7. Okay, let's try this again. 680.4. All right. So now notice what happens. So this one we had take the $1,200 in 5 years. Down here, it's flip-flopped. Denise should take the $1,000 in 3 years. It's worth more than the $1,200 in 5 years. Okay. So notice that at 8%, the decision was the $1,200. So at 8%, we should take this, and at 12%, we should take the other one. So it changes which one we take based on the percentage. So that's kind of the moral of this page. The moral of this page is the time value of money can have an impact on the decision, even if nothing else changes. It's the same $1,000 and $1,200 and $1,000 in 3 years or $1,200 in 5 years that grandma's giving you or giving her niece. Was the aunt? I don't know. Whoever was getting it, the choices were exactly the same. The only thing that changed was the inflation rate from 8% to 12%. That can have an impact on the decision. It can change your decision based on the inflation. So that's that was the important part of that page, is that it is important to keep those things, those calculations in there to beat the time value of money, because it can affect your decision and the decision you're making today. Okay. All right. Oh, it's orphaned. All right. Fred. Okay, Fred promised to pay his nephew $1,000 at the end of each year for the next 3 years. The discount rate is 8%. What is Uncle Fred's gift worth today? Okay. Here. Okay, so here, this is a little different now. So Uncle Fred is going to give, let's get up all this. He's going to give $1,000 each year for the next 3 years. Okay, so what we're going to do is discount these back to today. So this will be from period 1. Three. The discount rate's 8%. Okay, so we're going to use the same present value table. All right, so 8%, and each of these $1,000. I'm just going to copy these in. Okay, so coming over here, 8%. So period 1 would look like this. At one period, it would come out to 926. Okay, so that's what this first one would be worth. The second one would be worth this. 857. And the third one would be the 794. Okay. So the total would look like this. Add all those up. Okay. Now I want to show you something that we do to kind of save time. Notice that I don't know what I'm doing here. No, notice that I don't know how to use a computer. Notice that what we could do is, instead of multiplying all these out, we could simply add these up and multiply it once by 1,000. Because these are all the same. So notice that we could actually do this and get the same 25. Right? We could do it this way too. There's actually a table that will do this for us. If you click on the annuity table, or if you go to the end, the very last table on the handout, if you go to the annuity table, present value of an ordinary annuity. What is an annuity? Annuity is when all the payments are equal. So because all these payments are equal, yeah. So notice that each one of these payments is equal. So as long as the payments are equal, we can use the annuity table. Now here's the beauty of the annuity table. We just have to do one calculation. 8% for 3 periods. Let me clean this up in a second here. So notice that this 2.577, this is actually on the annuity table. And this annuity table is just what we just did. It just takes all the stuff from the single payment table and adds them up to the annuity table. You know, this is just a total from the single payment table. That's all it is. So to make things quicker. Now, for 3 items, it probably isn't that big a deal. Probably either table would take you around the same amount of time. But if you had a lot more items, like 30, it would definitely be better off doing it with a annuity table. So we're going to do an annuity one here next. Fred. Okay. Fred promises to pay his nephew $1,000 at the end of each year for the next 7 years. Okay, now $1,000. It's not gonna fit on here. Let me see if I can do something here. Okay, so we could use the single payment table. We could go through 7 calculations on the single payment table. We could go back to the single payment table. We could do 7 payments at 6%. We could do 7 of them. And there's nothing wrong with that. You can always use a single payment table. Right. So, just to reiterate that, you can always use the single payment table. The annuity table is there because it saves us time. We can go through 7 calculations, okay, the first 1,000 at year 1, 1 year period out, second one, 2 periods out, third one, 3, all the way on to 7 years. We could do 7 calculations, add them all up. A lot of times it's quicker just to do them all at once using the annuity table. So that's what we're going to do next. So and I know you guys have probably seen this before. So yeah, let me take a look. So this is for 7 periods. Interest rate is 6%. And this is an annuity. So we could use the single payment table, but let's use the annuity table because it is way faster. So annuity. Okay, so let's go to the annuity table. So annuity table, we go to, so we don't want to do 7 calculations. We're going to do 1 calculation. $1,000, 7 years, 6%. Okay, so okay. All right, so we go to 7 years. 6%. Our factor is 5.2. So today, we're gonna bring this back to period 1. This period 1 we're gonna bring back. I'm just gonna do it down here. See, $1,000. This is actually for periods 1 through 7. Maybe I'll put that in. I know I abbreviated that. Okay, so 1,000 times 5.582 equals okay. So this would be the value of that. This is a gift, isn't it? Yeah. And again, we could go through 7 of the single payments, and you should get the same answer. It might be off a little bit because of rounding, but it should be pretty close. You know, we could always do this. I always do the wrong sheet. Holding. Get out of here, you. Yeah, we could do them all individually, or we could just do this. And you should get the same answer or something pretty close to it. Let's stop here. Okay. So this is the kind of the present value stuff. It's getting used to using the table and figuring out what the present value is. And again, the annuity table. Make these a little better. Oh, I made it worse. I don't know. What I want to tell you is if there are payments that are different. So for instance, if this is say a 4,000, at this point you could not use the annuity table. If they're not exactly the same, you can't use the annuity table. And someone may say, well, can you average them? No, you can't, because if you average them, it's going to put some of these dollars in different years, and they're not worth the same. So unless it is, all these are exactly the same, and I wish my formatting was a little better here. Unless these were all the same, you can't use the annuity table if it is not, they are not all exactly the same. I'm just going to leave it. Oh, wait, I know what I can do. Oh, I got an idea. There you go, kind of. Okay. Any question on that? Okay, so hold on to this handout. Don't turn this in. The practice exam you can turn in, and I will be mailing out the Chapter 11 exam. Will be mailed out tonight, and we do Friday 4/26. Weeks now. We're getting close to the end of this thing. Okay, don't leave. Let me get a screenshot. Make sure it took. And it did. Okay. Any questions? All right, go out and enjoy the beautiful day. See you guys in a week.